Good day, everyone. Today, we're exploring one of the most important ideas in statistical decision making, type 1 and type 2 errors. Let's start with type 1 error. This happens when we reject a true null hypothesis. In simple terms, it's a false positive. We conclude that something is happening even though nothing has actually changed. A helpful way to remember it is through a fire alarm analogy. A type 1 error is like an alarm going off even when there is no fire. Now, let's look at type 2 error, which is the opposite. This happens when we fail to reject a false null hypothesis. This means we miss something that is actually real, also known as a false negative. Using the same analogy, this error occurs when the fire alarm fails to ring, even though there really is a fire. It's a missed detection. To distinguish between type 1 and type 2 errors in any situation, follow this simple process. Step 1. Clearly state your hypothesis. Step 2. Ask if the conclusion rejects the null hypothesis when the null hypothesis is true, then it is type 1 error. However, if the conclusion fails to reject the null hypothesis when the null hypothesis is false, then it is a type 2 error. Step 3. Think of it as a type 1 error is a false alarm. On the other hand, a type 2 error is a missed detection. Let's apply this to a real scenario. Imagine a professor at Bat State U tests a new simulation-based study method to improve electrical engineering students' grades in circuit analysis. Our null hypothesis is the new method has no effect on performance. On the other hand, our alternative hypothesis is the new method improves performance. Here's what could go wrong. In type 1 error, professors conclude that the new method works, even though it doesn't. This means time, money, and effort are wasted on an ineffective strategy. On the other hand, in type 2 error, professors conclude that the method has no effect, even though it actually helps. A beneficial tool is ignored and students miss out on potential improvement. Both errors have consequences, just in different ways. Our next example involves an electrical engineering laboratory testing a new circuit breaker to see if it trips properly when there is an overload. Our null hypothesis is the circuit breaker is safe and functions properly. Then, our alternative hypothesis is the circuit breaker is faulty. Here, the stakes are higher. Our type 1 error, the team concludes the breaker is faulty, even though it's actually safe. This leads to an unnecessary replacement costs, but it is not dangerous. Then, our type 2 error, they conclude the breaker is safe, even though it's faulty. This poses serious risks, electrical accidents, equipment damage, and possible injury. In this example, the type 2 error is much more critical. Our next example is Bat State U uses an entrance test to select qualified applicants for the electrical engineering program. Our null hypothesis is the applicant is not qualified. Then, our alternative hypothesis is the applicant is qualified. Here's what the statistical errors mean. Our type 1 error. A qualified applicant is rejected. A capable student loses a valuable opportunity to study in the program. Then, our type 2 error. An unqualified applicant is admitted. This may cause the student to struggle academically and could lower program standards. Both situations affect students and the institution in meaningful ways. Understanding type 1 and type 2 errors helps us make better decisions, design better experiments, and avoid potentially cost consequences in research, engineering, and real life situations. Thank you for listening.